Hey, physics friends. I'll tell you, after seeing 3 children born, I'm just amazed every single time. It's probably the pinnacle of the human experience is to watch another person being born or to give birth to another person. Maybe you'll have that privilege sometime in your life, but it's pretty cool. Um, it's not for the squeamish either, that's for sure. With that said, I wanted to just take you through this quiz, take you through how I get exactly the answers that I got if you need any help. So let's get started. So here I've got a parallel circuit, and the trick to parallel circuits is knowing that the voltage across each of these components is all 10 volts. Or I'm sorry, not 10, but 18 volts. So this right here, this is going to read 18 volts, and so is this. So that's why M4 is going to be 18 volts, and also M5 is also going to be 18 volts. To figure out this one, M3, that's measuring current. So if you use the whole idea of V equals IR, and the voltage across this, because they're all in parallel, the voltage is 18 volts. And the resistance is 250, so you can now find I. And that turns out to be 0.072 amps. So that's what M3 is. Let's see. M number 2. To figure out M2, you have to figure out how much current is flowing through this branch, how much current is flowing through this branch, which we already know is 0.072, and then you have to figure out how much current is flowing through this branch, and then add them all together. So using V equals IR, so 18 equals I times 75. So the current flowing through this one right here is 0.12. This one here, 18 equals I times 125. So the current running through this branch turns out to be 0.144. So if you add these 3 branches up, you're going to get M2, and that comes out to be 0.46. Now M number 1, it's 0.46 amps plus however much is going through this branch, and this branch has 0.12 amps. So you take 0.46 plus 0.12 and you get 0.58 amps. So that's how you figure out a parallel circuit. The trick is all of the voltage is the same. So the voltage across each one, I all know, is 18 volts. It's simple. If this was a series circuit, the current running through every single one of these things would be the same. So just knowing that the voltage is the same is the key to solving this entire problem. Number 6, a package of 6 AAA batteries costs this much. Each battery is this, and one of those batteries is put into a device that draws 300 milliamps. Watch out for that, because you're going to want to know that this is 0.3 amps, first of all. And it operates continually for 220 weeks. Yikes, that's crazy. That's like 4 years. Calculate the cost per kilowatt hour. So what I want to do, I'm going to end up doing a bunch of dimensional analysis stuff, and I want it to equal $ per kilowatt hour. So first of all, I know one battery is $5.67 per battery. And I use 6 batteries. So that's $5.06 for 6 batteries. So we'll just do that. 6 batteries. I could figure out how much it costs for one, but I don't need to because I already have the 6 in the denominator. So I need to figure out the power and then the hours also. So let's start with weeks. So I've got 220 weeks, and I can change weeks. 1 week is 7 days, and 1 day is 24 hours. So you multiply those things together and you get 36,900 hours. So that'll go down here, 36,900 hours. Good. Another check in the box. So I've got $ taken care of. I've got hours. Now I just got to figure out how many kilowatts this thing is. So let's find the power. Power is current times voltage. And I know the current 0.3, and I know the voltage, sweet, 1.5. So if you take 0.3 times 1.5, you get 0.45 watts. So 0.45 watts, and I'll just change watts into kilowatts. So there's 1,000 watts in 1 kilowatt. There. Now we've got it. We've got the kilowatts checked. Now what you do is you multiply everything on the top, divide by everything on the bottom, and you end up with $0.057 per kilowatt hour. 5.7 cents per kilowatt hour. And then the last one. Number 7. An electric aquarium heater is rated at 250 watts. That might be helpful to know that it's also 250 joules per second. That's what a watt is. The heater is submerged in 5 gallons of water. The electricity is this much. Part A, how long does it take to raise the temperature of the water from room temperature to 27 degrees, assuming that all the heat gets put into the water? And part B, how much does it cost to do that? So part A, I'm going to go Q equals MC delta T. How long does it take? So I know that it's 18.9 kilograms. The specific heat of water is 4180. And the change in temperature, you're going from 20 to 27, which turns out to be 7 degrees Celsius. So you can figure out how much energy it takes. It takes 553,000 joules to do so. Now, my heater is pumping this many joules into it per second. So I've got, let's see how I could maybe do this. I think I'll say that every second I am operating this thing, I'm inserting 250 joules. And then I have to multiply by 553,000 joules. A little bit of clever dimensional analysis, so joules cancel out. And that equals 2,212 seconds. Converting that into hours is 0.614. Because there's 3,600 seconds in an hour, so it's like a little bit 0.61 hours. That's part A. Part B says how much does it cost to do that? Let's see. So I know that it's $0.112 per kilowatt hour. And I know that 1 kilowatt hour is 3,600,000 joules. I just remember that from earlier in the chapter. And then I'm using 553,000 joules. Hey, look at there. Multiply everything on the top by everything on the bottom, and you get $0.018. 2 cents to heat up your aquarium heater. Well, friends, it's been fun. I thoroughly enjoyed my time with you just now. I can't wait to see you next week. Be good.